All right, so the perpendicular bisector theorem proof. So the reason why this theorem works. So a reminder of what the theorem is. The theorem states in a plane, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So that says that if we have our perpendicular bisector, so right here, we can say for sure that CP is a perpendicular bisector of AB. We've got the right angle markings for that perpendicular piece. Bisector, it's cutting AB in half. So point P cuts AB in half, meaning perpendicular bisector. So a consequence of that is in that CA is equal to CB. Now there is a reason for this, and this is the reason why this theorem is true, and it all stems back to what we did in Unit 4 with congruent triangles. So I do want to walk you through the proof just so it kind of helps you get a better understanding of why these theorems hold true, and sometimes when we understand that why, it really helps us to apply it even better. So the first statement that we need to, give is those givens. Those givens are always super crucial. So the first given is that CP, so line CP, is a perpendicular bisector of AB. We do need to make sure that we state that. So then the next given is that AP is congruent to BP. So that is given mostly by the diagram because you see those markings, but also it's that definition of bisector. So it's got that dual piece. So we do know that it is given in that bisector understanding. And then also we're given that we have right angles because we know if angle BPC is that right angle because it's got the right angle marking, then the other side is also going to be a right angle due to our linear pair postulate and the definition of that perpendicular. All four angles become right angles, so we can say for sure that APC is congruent to angle BPC. Yeah, those two right angles. So then the next piece is the reflexive property of congruence. So if you look here, we've got two triangles that we can work with. We've got triangle CPA, this triangle right here, and we've got triangle CPB. So we've stated that this side is congruent to this side. We've got the two right angles. So then we also see that they share a side. That reflexive property tells us that if two things share a side, that side is going to be congruent to itself because it is the same object. So we can say that CP is congruent to CP by that reflexive property. So now we have shown by the side angle side congruence postulate that those two triangles are congruent. We've got triangle APC is congruent to triangle BPC by that side angle side congruence postulate. We've got side angles, the right angles, and then the last side is the side that they share, that's CP. So now that we've shown that the two triangles are congruent, we can say that CA is congruent to CB by that amazing CPCTC, corresponding parts of congruent triangles, because we just showed that those two triangles are congruent. Those corresponding parts then are congruent. So that's the last piece, is that CA is congruent to CB, which then makes that that perpendicular bisector theorem true, that then it is equidistant from the endpoints of the segment, that piece right there. So I just wanted to walk you through this theorem, make sure you understand why it is true, why it holds true every time, and just kind of give you that better understanding of proofs and the logic behind it. So hopefully this was helpful for you. If you have any questions, please let me know.